Hello everyone. So today I am going to explain about how to find whether a given binary tree is a binary search tree or not. So let's discuss the question. So the question is that we will be given a binary tree and we have to determine whether a given binary tree is a binary search tree or not. As you can see here, 2, 1, 3. As you can see, the one which is present on the left hand side of 2 is smaller than 2, and the 3 which is present on the right hand side of the root is greater than 2. So this case is the binary. This binary tree is the binary search tree. So the main definition of the binary search tree is that whatever the element which is present at the left of the root should be smaller than the root value, and whatever the element which is present on the right of the root should be greater than the root value. As you can see the second case, in second case, we can see that one which is present at the left hand side of 5 is smaller than 5. This one is valid binary search tree up to this part, but when you see on the right hand side this 4 which is greater than 5 and it is present at the right hand side, so this is not a valid binary search tree. So here we will return false. I hope the question is clear to you. Now let's move to the intuition that how we are going to solve this question. So basically, in order to solve this question, I am using the range method that I am going to explain you. That for the first case, that means for the root node, we will be having the range from the minus infinity to infinity. As you can see here the minus infinity value is the value of the long int, and when we move to the left hand side, then its value will become minus infinity to 10, because this value should be greater than minus infinity, but it should be less than 10. That's why its range get reduced to minus infinity to 10. Then as we move to the left hand side, we can see here this value should be greater than minus 3, but should be less than 5. Why? Because this is present at the left hand side of the 5. Similarly, for this value, you can see here for right hand side 70. This value should be greater than 10 but less than the maximum value of the long int. But so here we are going to see the approach that if 5 is lying inside this range, then this 5 is correct. Means then this 5 node up to here is following the property of binary search tree. But if any node that is not lying inside this range, then we are simply going to return false, because this is not following the property of binary search tree. As you can see here 7, which is present at the right hand side of the 10 and is not lying in the range of 10 to maximum size of long int. So here we will return the false. I hope the approach is clear to you. Let's move to the coding part. So as I had explained you that here I am going to use two things. One is lower bound that I am going to use minus 150, and one is upper bound. Here lower bound and upper bound is representing the range of upper bound representing the range of each and every nodes that they should follow in order to be a valid binary search tree. Return valid BST, and here we are going to pass root value, then lower bound, and then upper bound. Okay, then here suppose if root value is equal to null, means we are not given any tree, then in that case that tree will be a valid binary search tree and we are simply going to return true. Okay, suppose the case is that if root value is greater than or equal to upper bound, or root value is lesser than equal to lower bound. So I am going to explain you this part. Here you can see that the root value is lesser than lower bound, so this is the invalid case. And you can see the other case also. Suppose here the element is 12, then in that case you can see that the root value is greater than upper bound. So in these two cases we have to return false, because it is not following the property of binary search tree. Means it is not lying inside that range, and as we have decided if any element is not lying inside that range, we are going to return false. Then for all the other cases, we are simply going to call two recursive function, that is valid binary search tree 2 times one for the left and one for the right. Left, comma. Here, as you can see here, when we are moving to the left hand side, then we are changing the upper bound to the root value. So I will change here the upper bound to the root value, that is root value. Or why I had used or, that I will explain you. Valid binary search tree. Right, root right, comma. As we are moving to the right hand side, then we are changing the lower bound to the root value. Why we are doing this? Because this value should be greater than this. Due to that reason we are changing. Okay. So here I will change this value, the root value, lower bound, then upper. Why I had used or here? As you can see here, in this case, when there is 7 here, in that case, this left subtree is following the property of binary search tree, but this right subtree is not following the property of binary search tree. So this will return true and this will return false. So in that case, what we want to return overall, we want to return false. So that's why we had used or here, because in or you know that if any of the condition become false, then the overall result can become false. Let me run the code and show it to you whether it is running fine or not. It is showing runtime error. Okay. Here I have to use long int, sorry. Long int. As I had explained, it is lying inside the integer edge, that's why it is giving the runtime error. Okay. Here we will not use or, here we will use and. Why? Because in that case, if this part is giving us true and this part is giving us false, then in our case it will return true, but we want to return false. That's why we have to use and here, not or. As you can see, the code get compiled successfully. Let me submit it. As you can see here, the code gets submitted successfully. Thank you for seeing the solution. If you think this video is helpful, then don't forget to like, share and subscribe to my channel. Thank you.